Alright, so let's take a look at Euclid's Book 1, Proposition 5. In isosceles triangles, the angles at the base are equal to one another, and if the equal straight lines be produced further, the angles under the base will be equal to one another. So what he's saying is not that we can make isosceles triangles, that's just a fact. He's like, get over it. You should know that by now. And he's more saying that these angles under the isosceles triangles, below the base, you would say, it could be above it, I guess, have the same property that the angle within the triangle is going to have. You're going to learn to call it exterior angles, or you might already know that. And let's just see if he's lying to us or not. Let's look at these numbers. Oh, didn't mean to do that. It's going to be the same angle, isn't it? Okay, here we go. For real this time. A, B, moment of truth. Put it on the... Yeah, y'all gotta make me put a point on this line. Just... sometimes. Okay. That point is not on the line. Awesome. Misclick. Redo. Put a point on the line. Let's make that angle. Ugh. There we go. Okay, so looks like he was telling the truth. But that's not good enough. Gotta make sure it works every time. So that's the whole point of geometry and what we're gonna do now. So let's take a radius EF and let's mark on this infinite line EB a segment the same size as EF. This would normally be done with a compass, but I'm using computer software, which I am not good at using. You're going to learn quickly. And we're going to add some segments here. Kind of crossing these. So we can try and use our proposition 4 or Hilbert's sixth axiom of congruence, side equals side, to get some useful results here pertaining to our angles FAB and GBA. So from here, we're going to begin by saying or noting that segment EF, EG, both raise the same circle, and EA and EB are contained within each of them respectively. So we can remove that segment or lay it off, however you want to say it, and from there we can go, oh, well then FA and GB probably share some properties, like being congruent. So let's give them their own little color so they can be buddies. We're going to give them green. Yeah, like that. And we're going to mark them. Same size. Da-da-da-da. It's real good. A lot of good vibrations from that I was feeling. And now we can just go, alright, let's look at triangle FEB and triangle GEA. And since we know FE congruent to GE, which way did I go about that? GEA. Okay, so we also know that EA is congruent to EB. So in each of these triangles, those parts are congruent, which means now that these crisscross segments down here, AG and BF, are going to be congruent to one another. So we'll just quickly give them a matching color. Black. Ooh, nice. And also we should note that the angles in these triangles are congruent to one another. So you could say that this whole angle down here is congruent, EBF, but that seems like it's not too useful considering we're trying to get at those whole angles. And we're not going to start adding angles up here anytime soon. So we're just going to mark this angle EFB and EGA of our congruent triangles. This angle and this angle. And now we're just going to take out the numbers because that's not real geometry. If you're using numbers, you're on something. Just get rid of the label altogether and just give it a color. Just give it that same maniacal green. I gave that line that neon stuff. I like it. No label. Same color. Awesome. Okay, so we've made it this far. Let's go. Got this. Alright, so we're looking at FAB. That's our new question, and GBA. So anything we could do now pertaining to those? Well, let's look at the triangles that contain the segments EFB. So in order here, EFB. And I just looked at that, didn't I? And EGA. Excuse me, we're going to look at these smaller triangles, ABG now. And so BAF. We're going to look at these guys, see what we can find out about them. We have these sides that I marked black are congruent with one another. So AG, and since I start from up here, we'll go BF. Those guys are congruent. We have this angle now congruent to one another, angle F, angle G. And we also have FA congruent to GB, which means these triangles are congruent. So the good news is we can just use our side angle side, and the congruent parts of congruent triangles are also congruent. We can use those facts to get at this guy right here, FAB and GBA, since they're contained within these congruent triangles. And from here, we can just say, well, hold on, let me look at these guys. Let's look at them. Let's no labels. No. We're gonna give them an awesome color, very bright color. Well, maybe not. This purple thing kind of works though for me. And we're gonna mark them off. And let's look at what we got. It almost looks like that might be the angle we were talking about in the first place. I think it is, folks. Alright, so there you have it. The exterior angles are also going to be congruent, corresponding to those congruent angles, that is, in an isosceles triangle. Alright, thanks for watching. Have a good day.